Greetings everyone. Today we're going to explore inverse matrices. First, we need to introduce what is an identity matrix. An identity matrix is a matrix with ones on the main diagonal and the rest of the values are 0. Here's some examples. So a 2 by 2 and a 3 by 3 would look like this. So why do we need an identity matrix? If you multiply any matrix by the identity matrix, you'll get the same matrix back. So think of this like the identity property of multiplication. If I multiply anything by 1, I still have the identity. My number, my value did not change. So we need to deal with identity matrices to find inverse matrices. So an inverse of a matrix undoes a matrix, kind of like adding a negative number to its positive, or by multiplying by a reciprocal. Now we need a special notation for inverses of matrices. We've been using capital letters to identify our matrices, and so we use this little exponent of to the negative 1 to show that it's the inverse matrix. The nice thing about that notation is that's also what we would use in our calculator to find the inverse. And again, we have some limits similar to determinants, right? We are only going to deal with square matrices. All right, so our first approach is going to be deciding if two matrices are inverses of each other. For example, a 2 plus a negative 2 would arrive at 0, or a 3 times 1/3 would arrive at 1. So our goal is, if we multiply these two matrices, for example, I should get the identity matrix if they are inverses. So let's take a look at this quick little example. If I'm going to multiply these two matrices, I'm going to have a 2 by 2 matrix. I like to set it up first, so let's say I'm looking at top left. I'm going to have negative 3 times 1 plus 10 times 0.4. We're going to add those two values together and we arrive at 1. Perfect, we're on the right track. Top right, we're going to take a look at that. I'm going to have negative 3 times negative 2, and I'm going to have 10 times negative 0.6. So if I multiply those and then add, I would arrive at 0. Still on the right track. Bottom left. Bottom left would get me to negative 2 times 1 plus 5 times 0.4. So if I multiply those, I arrive at 0. So far, so good. And the last would be bottom right. Bottom would be negative 2 times negative 2 and 5 times negative 0.6, which would get me to a 1. So in this case, that's good. That's what I needed, right? I needed the identity matrix, so our final answer would be yes. So to check if they're inverses is pretty simple, but we also want to find inverses. So this is a little bit more of a process where I would need to see some work. So if I want to find the inverse of this 2 by 2 matrix, here are some steps. So if you're a rule follower, definitely write these down. Considering when I say A and D, I'm talking about this type of matrix. So first step, if I change A and D around, so I'm swapping them, I change the signs of C and B, meaning if they're positive, negative, negative, positive. We're going to find the determinant of the original matrix. And then we're going to take a scalar. We're going to multiply that matrix by 1 over the determinant. So let's try this out with this matrix A. Our goal is to find the inverse. So I'm going to swap the A and the D around. I'm going to change the signs of C and B. I'm going to find the determinant of the original matrix. So let's see, that would get me to negative 40, negative 77. We're going to subtract, which changes to adding, which gets me to, let's see, what do we got, 37? So there's my determinant, 37. And I'm going to multiply this matrix by 1 over the determinant. Oh boy, let's take a look here. So if I distribute this, look at how messy this gets. 8 times 1/37, 7 times 1/37, negative 11 times 1/37, and negative 5 times 1/37. So this inverse matrix is messy, and they will be messy. So we will also take a look calculator-wise, but as well we can find the inverse by typing in matrix, storing it, and taking it to the -1 power. All right, let's take a look at another example and walk through the steps. The first step we're going to deal with, we are going to swap A and D. We're going to change the signs of B and C. We're then going to find the determinant of the original matrix. So I have a negative 16 and a negative 18. So negative 16 minus negative 18. Nice clean 2. All right, so we've got a nice easy number. We're going to scalar multiply this new matrix by 1 over 2. So this one should be a little bit cleaner, right? So my inverse of A will be, if I distribute a half, 4, negative 1, 9 halves, and negative 1. Now please leave these as improper fractions. We'll go over how to change a decimal to a fraction in your calculator if that's what it gives you, but I want to see improper fractions. Let's look at one more. If I want to find the inverse of B. So first of all, I'm going to swap A and D. I'm going to change the signs of B and C. I'm going to find the determinant of the original. So we've got 5. We're going to take 1 over the determinant and distribute or scalar multiply. So the inverse of B, this one's going to be a little bit messier matrix, right? I'm going to have 3/5. And that's what's nice, because it's going to be 1 over a number, the multiplying is going to be pretty straightforward. I'm going to have 1/5 here, I'm going to have 1/5 here, and negative 2/5 here. All right, when we look at the inverse of a 3 by 3, actually, we're not even going to look at it. It's just too much. So we're going to go straight to our calculator in order to find the inverse of a 3 by 3. So when it comes to work, 2 by 2s, I want to see some work. Can you check with your calculator? Of course. 3 by 3s, I'm not going to see much work. I want you to use your calculator. Okay, so since we are going to use calculating devices for our 3 by 3, let's start with this matrix, and we'll look at Desmos first. All right, so for 3 by 3, let's start off by looking at Desmos, and then I'll also look at the graphing calculator. So on Desmos, let's type in, we're going to go to desmos.com/matrix, and what we're going to do is we're going to choose new matrix, and we're going to type in our 3 by 3. So this is the same one I provided on the slide. Oops, see, I'm used to pressing enter. Don't press enter until you have all your values in. All right. Now, for the inverse, what I like about Desmos is the power to the -1 is already there for you. So we're just going to do A matrix, because that's what I named it as, to the -1. And you'll notice off to the right, there is our inverse matrix. So yes, it is that simple to to get an inverse matrix on Desmos. Now, this is helpful on homework and practice, not so helpful on a learning check. So let's check out a graphing calculator. All right, so this time we're looking at our graphing calculator. To create a matrix, I'm going to go second matrix. Choose either a blank one or one you want to edit. I'm going to choose to edit D. So I need to go over to edit, and I'm going to select D. It's a 3 by 3 matrix. Be careful, subtraction versus negative is different. So negative's at the bottom. So -4, -3, 2, 1, 1, -2, 3, 2, -1. All right, so there I have saved my matrix D. So I'm going to go second quit. Oops, second quit. There we go. Back to the home screen. I'm going to go second matrix, and I need to be under names to select my matrix D. That brings D, and I want to go to the negative first power. So you have that button right where we clicked matrix to the negative first, or if you use caret top and type in -1. So I'm going to do a quick to the -1, and I'm going to press equals, and there again I have my inverse matrix. And there we go. That is how we find matrices 3 by 3 in the calculator, 2 by 2 by hand. And we're going to use these inverse matrices in the future. So today we're just concentrating on the how. So again, please remember that if it's a 2 by 2, I want to see some work. If it's a 3 by 3, we're going to use a calculating device. Make sure, as always, you check Google Classroom. Do you have any more tasks or anything else to do? And until next time, have a good one.